Greetings, Patriots. This is Miss King, and we're going to go ahead and stop right here. Open up your notebook. Make sure that you prepare your notes for this lesson, and this is lesson 3. We're going to be looking at how a constant rate of change looks like in a table, in a graph, and an equation. So the past 2 days, we went from a table, then to a graph, and today we're adding the equation, okay? Same thing. We're going to start with building houses like we have had in the past 2 days. So let's go ahead and go to our next slide. I will represent a situation in an equation. That's our objective. So we're going to want to look at where do we see that rate of change, that constant rate of change in the equation. All right, so let's kind of refresh. We started by building a house, right? We had house number 0 had 0 pieces. Then we went to house number 1 and it had 3 pieces. Now we even graphed that relationship and we saw what our graph looked like as well. So I want you to consider what's happening between the house number and the total pieces. So if I ask you, can you predict how many total pieces are in house 10? What would you do? Okay, so let's think about what's happening now between the house number and the total pieces. This would be a good place for you to write some notes in your table, in your guided notes, or create a table in your notes and you can set it up. So I know that as I go from 0 to 3, I'm definitely adding 3, right, pieces to the house each and every time. So I see this constant addition of 3. Well, if I begin to look at another way that I can write this, I know that 3 times 1, house number 1, would give me 3 pieces. Let's see if that same pattern works for the second house. 3 times 2, 3 groups of 2. Okay, well, that is 6. That's correct. Let's try the next one. 3 plus 3 plus 3 is also equal to 3 times 3, which is equal to 9. And then 4 times 4 groups of 3. 3 times 4 equals 12. So do you see this nice pattern as I look at the house number to the total pieces? That's my rule. That's that process that's occurring from each variable, from house number to total pieces. So what if I said, what would we do with house 10? How many total pieces would you get? Think about that process. Would it continue to work? Okay, so 3 times 0 is equal to 0. So think about it. Your number, your house number continues to change. I can just call that H because it can be house number 1, house number 2, house number 3, right? It's a variable. It varies. So total pieces. Something's happening to each house in order for me to get my total pieces. So my total pieces is also changing. So we add another variable. So when I think about that, I get, well, what's happening? I'm taking 3 and I'm multiplying that by the house number. So 3 times H, you see that constant of 3? The house is the number that varies, so you can see that nicely in the table. That'll always give you your total pieces. I can take that information, what's beautiful, and write an equation because I can ask you to predict a variety of total pieces for any number of house. So there is your equation. 3 times H equals the total pieces. I can also say, in order to get the total pieces of any house, I got to multiply 3 times the house number. And the way we'll be writing our equations is we will be calling our dependent variable, our total pieces, Y. I can call it any letter, okay? But this is how you'll normally see it written. Y equals 3 times X, 3 times the house number. Please remember, it's understood that between 3 and X, between that coefficient, that number, and that variable, that signifies we're multiplying. Okay, so make sure you wrote that equation down because what I want you to do is now think about that word, that question that we asked. Where is that constant rate of change? Where's that constant rate of change in your equation, right? Where is it? I want you to think, where's the constant rate of change in this equation? Write your answer here. You can actually write it on the slide if you're taking notes. But also, what does the constant rate of change mean? What does it represent in this situation? What do you think that constant rate means? Go ahead and take the time and write that in your notebook because we will discuss it tomorrow. Okay? So, did we have the opportunity to represent a situation in an equation? Yes, we did. I can check that off. The last question we're going to talk about in class is how is that rate of change indicated in that equation? Okay? How is it being used? What pattern do you see? All right, Patriots, have a wonderful day.